All right. So I've started recording the class. All right.
Mm,
Now let me know once you're able to see my screen. Okay. Now you have to tell me when you're able to see the screen.
I can see it.
Okay. How about the white screen? Can you see the white screen now?
Yes.
Okay. Wonderful. So Daddy has sent me the syllabus. Okay.
Hmm.
So what I'm thinking is I'll start with the uh, the first chapter. Okay, let's quickly look at the number systems and see if you're all comfortable with that,
Okay.
and if there's any gaps, we'll try bridging that, and then we'll keep moving on. Okay.
All right. Yeah.
Okay. So I'll ask you some stupid questions. Bear with me.
Okay.
Do you know what is this?
Yes.
Uh, I mean, okay. Let me not be that stupid. So this is a number line, correct?
Yeah.
And then on this number line, we start from zero on one side and
Hmm.
go the positive direction. This is negative direction. Yeah. Here
Yes.
we have negative numbers. This side we have positive numbers.
Hmm.
Now, what is a natural number?
Natural number is any positive integer.
Yes, everything that is after zero and
Hmm.
positive. If you include zero, this set is called
Uh,
ze- zero included with positive. That is called whole numbers.
whole numbers. Okay.
And if you include negatives also, that becomes integer. So basically, when we say integer, that includes natural numbers plus whole numbers plus negatives. Yep.
Hmm.
So integer is nothing but the parent of all
Yeah.
types of numbers. Positives, be it negatives or zero. Only difference between natural number and whole number is the whole number has zero included.
Hmm.
Natural number doesn't.
Okay.
Okay, that's on this one. Now, so we covered natural numbers, integers. Now, do you know what is a prime number?
Yes. It's a number that's divisible only by one on itself.
Wonderful. I will not waste your time. Let's go. Square numbers.
Square numbers. Yeah. It's when you multiply a number by itself.
Mhm. And that forms a number. That number, which is formed by square of another number, is square number.
Hmm.
If I say 9, it's equal
Nine.
to this, and that's why 9 is called a square number.
Mm.
I will not call 3 as a square number, correct?
Okay.
Yeah. Now, if I say 25, this is also a square number because this is formed by square of a number. I mean, that's how
Yes.
we'll read it in English, right? A
Hmm.
square number is a number that is formed by square of some other number.
Hmm.
Yeah. So all these numbers are square numbers. And I can just go on. Yeah.
Yeah.
This is square of 1, the square, sorry, I missed this guy. The square of 2, square of 3, square of, sorry, I missed this guy also. Square of 4, square of 5, 6, 7, 8, 9, 10, 11, so on and so forth. There's nothing tricky about it, so I'm just skimming through this. Okay.
Hmm.
Same way, if somebody says cube numbers, just extension of square number,
Yeah.
any number that is formed by cube of a number, cube of another number, or same number. Like in case of 1 is a cube of this. So here, this guy is a cube number, but also a cube of itself. But if I look at 8, it's a cube of 3, which is a different number. So that's why I was saying a cube number is a number which is formed by cube of same number or another number. And That same number comes into play only because of this one guy. Yeah,
Mm-hmm.
clear, no doubt.
Yes.
I'm just skimming through these, easy ones, right? So that no,
Yeah, of
we
course.
get time to look at. Okay, then now comes common factor. Or before we do that, there's something called LCM and something called HCF. Have you dealt with these two guys?
Yes, the lowest common multiple and the highest common factor.
Yes. So I've seen, even when I was a kid, I never bothered to think about why do I need to deal with LCM or SCM? What is the significance of these guys, right? Why do I have to
Mm-hmm.
even worry about it? But I never bothered to kind of expand this and say, okay, lowest common multiple, lowest common multiple. So what exactly does it do? If I have, let's say, a number two and a three, what is
Yes.
LCM for that? I know how to do it. Yeah, I have done it enough. But trust me, I never bothered to think about it. And that is where we learn, but we forget. So today I'm going to enforce that, or avoid that mistake that I committed for myself. So
Okay.
if you look at LCM, in very simple terms, I'm trying to find out what is the lowest common multiple, meaning the smallest number that is a multiple of this and this both. Smallest possible number that is a multiple of this and this. If I can talk about it like a child, I will say a smallest number which comes in table of 2 and table of 3 both.
Mm-hmm.
Now, somebody says, okay, find out LCM of 2, 3, and 8. Here, we will start putting this line and start doing the LCM. No, don't do that. Think, what is that we are trying to find out? LCM meaning the smallest number that can be divided by this, and this. All.
Mm.
If I take 6, it's a LCM of these two, but it comes nowhere in picture when it comes to 8. Yeah.
Yeah.
So that's why when you keep on adding more and more numbers, keep making more and more diverse, ultimately the objective is to find out a number, a smallest possible number, which falls in the table of this guy, and this guy. We'll keep that in mind. Okay.
Yes.
So now, how to do it? I'm sure you would have done it 100 times. I don't have any doubt about it, how to find it out. But keeping that concept in mind that yes, I'm doing LCM because LCM is no, a method for me to find out which is the smallest number that can be divided by the numbers for which I'm trying to find out the LCM. Yeah.
Mm-hmm.
So simple thing is, I mean, again, I know I'm stretching this, but if I say no, I'll not say two and three. I'll say two, three, two and three. I find out the LCM is 6, but this is the lowest common multiple. But again, that means 6 comes in the table of 2 and 3 both. But at the same time, I know, I mean, by 6 is a number that can be divided by 2 and can be divided by 3. So is the case with 12. 12 also can be divided by 2 and 3 both. So is the case with 18. It can also be divided by 2 and 3. Here, among the three numbers that we see for reference, this is the lowest common multiple, meaning this is the smallest number that can be divided by the numbers that we are trying to find out the LCM for. Okay, I think we
Mm-hmm.
have talked enough over that.
Okay.
Now let's go to SCF, highest common factor. Now, don't look at this like a math. Think about it
Okay.
like English. Highest common factor. Let's park this now. Now let's look at a number. I can say 2 as 2 or 2 into 1, both the same.
Mm-hmm.
Here, 2 and 1 are factors of 2. Now let's look at 3. I can write this as 3 into 1. So these are factors. What do we mean by factors? Meaning any number that I can multiply with something to get this, right? Let's say I did not score well in an exam. My
Yeah.
parents will say, what was the reason for you to get a lower score? And what were the factors that contributed for your lower score? Right? Factors
Mhm.
meaning the elements that make it up. Yeah.
Okay.
Yeah. So when you say factor, factor is in very simple terms, you are breaking it into small pieces and then you say these are factors. Now let's look at 6. 6 I can write as 6 into 1, or I can write this as 2 into 3. Yeah. So
Mhm.
basically it says 6 and 1 are factors. Similarly, 2 and 3 are also factors, meaning they are the things that can make 6. Meaning, if you pick up any of these numbers, you can multiply it by something else to get this. So
Yeah.
here it turns out to be 6. 6 has factors like 1, 2, 3, and 6. Okay. So let's take one more number and then we'll come back to our main agenda, what we are trying to do. So if I look at 12, same way, I can say uh, we did for 6 and we found out that 6 has factors like 1, 2, 3, and 6. Okay. Now
Okay.
if you look at 12, again same thing. I can write this as 12 into 1, or I can write this into as 4 into 3, or I can write this as 6 into 2. So
Mhm.
what are the factors that 12 has? 1, 2, 3, 4, 6, 12. Yeah. So if you look at 6 and 12, they have different factors. When you say HCF or highest common factor, what is the big deal? What is the highest common factor? Highest factor which is common in both the numbers, 12 and 6. What would be your answer? If I
Mm.
say, what is the HCF for 6 and 12? Now you have all the factors written down here.
Yeah.
So what is the HCF for 6 and 12?
I'd say 12.
No. Highest factor which is common in both of them.
Okay. So it would be 6 then.
Yes. So basically, that's why I was saying that it's very important for us to know what do we mean by factor in English terms, okay? And then we broke it down and found the factors. Now, what is the factor for 12? We broke it down. When we say highest common factor, highest common and factor. Factors, these are the factors. Highest, these are the I mean, highest common. So something which is common and the highest. See here, 2 and these 2 are common. 3 and these 3 are common. 6 and 6 are common. But then we are talking about the highest. That's why we pick up 6. And that is my SCF. Yeah.
Yes.
So now you will tell me, why would we even need to worry about it? Why do I need to find out SCF? Because, like, why do we need to find out LCM for any numbers? It just tells you to. It just gives you the ability to find out which number. Let's say I have to find out. Let's say I'm doing this sum. Okay. So then, when you to find out LCM for these two, you find out, okay, let me find out a number which is multiple of this and this both, and that is smallest. I don't want to put 64. This is not the smallest, this is not the lowest common multiple. This is a probably much bigger. So it helps you find out what number you'll multiply by this and this to get to a point which is in this table and this table both. Similarly, if you're, let's say, talking about multiply 246 plus 128, let's say. If you have to add them, I mean, I'm probably giving a very simple example. Uh, yeah, let me do this way. Let's say 1005 plus 2010 plus 680, whatever. I mean, just making it up.
Okay.
If you find out the HCF for these three numbers, which is the highest common multiple, what you can do is, okay, let's say 5 is the highest common multiple here. I'm just taking it out.
Okay.
Then what happens is this becomes 201 plus this becomes 402 plus this becomes 136. Then basically, it just helps you simplify the sum. Okay, you will add the smaller numbers. Maybe this was not the right example. Adding these three numbers would have been much easier, but SCF tells you to break the bigger calculation to smaller calculation. So basically you take out the common things and then you deal with the smaller numbers, and you can do your calculation faster. Okay, so LCM and SCM both are there for a purpose. HCF just helps you convert the bigger number to a smaller number by taking the common factors out. Yeah. Or let's
Yes.
look at this example. I mean, I know this is also not a very good example, but if I'm talking about 8 plus 24, okay, I'm just, this is a very bad example, but still, okay. Here I know 8, 24 is in the table of 8, or 24 also has one common factor. 8 is a common factor among both of them, right? So then this becomes 8 into 3 plus 1, 4. Okay. And that, again, 8 plus 24 is 32. Everybody can figure it out. But what I'm saying
Yeah.
is, probably if you look at this problem in a broader sense, you will find that SCF helps you to take out the common factors and deal with a smaller calculations. Yeah.
Okay.
Now let's look at this. Okay. I got a better example. Okay, 10 to the power 3 plus 10 to the power 6. Okay,
Yeah.
if you have to do this, now one thing you will find out, okay, 10 to the power 3 is a HCF, highest common factor, because this can be multiplied by something to get this. Okay, so this becomes 1 plus 10 to the power 3. This is an exponent problem. I'm not sure we have not done exponents in our class for sure, but you might be knowing it. If not, we'll cover it anyways. Okay.
Okay.
So what happens is, instead of dealing with this 1,000 plus a million, you end up converting this into smaller fraction factor. It becomes 10 to the power 3 plus into 10 to the power 3 is 1,000 plus 1, 1,001. And then you can multiply this. So it becomes 1,000 in 2001. So basically, it just helps you simplify this, take out the common things, and then deal with it. Okay, so I think we talked enough about it. We will appreciate it more when we do usage of this in the concepts that we learn later on. Yeah. So LCM, SCF, we just revised more from a usage point of view. Okay. Yeah.
Yes.
Now tell me, what is rational and what is irrational number?
Well, a rational number. Um,
Okay. Um, I know this is something that we only learn. Okay, we don't end up using a lot, and even if we use, we just use it like a math. Okay, so definition you might not remember. Let me give you the uh, example with the number line. So
okay.
far in the number line, we saw that we can represent these numbers.
Yes.
Now we also know that between 0 and 1 also there are certain things, right? You would have seen those small lines. Yeah, like a scale that we, or a ruler that we deal with.
Mm-hmm.
Yeah. Between 0 and 1 also you have some interim points. that
Yeah.
represents like a decimal. Yeah,
Yeah.
point 1, point 2, point 3, and then you reach no 1, 1.1, 1.2, and then you reach 2, right?
Yeah.
So basically, number line represents the integers, as well as it represents the decimals or fractions. Okay. So
Yes.
anything that can be plotted on a number line, that is called a rational number. So basically, it
Mhm.
includes your integers, meaning when I say integer, I'm talking about natural number, I'm talking about whole number, I'm talking about integers, all, everything, right? The
Yeah.
superset. And then the fractions, 1 by 2, 3 by 9, 6 by 14, whatever. Yeah. And that converts into decimals. Yeah. So anything and everything that can be plotted on a number line is called rational number. Now, do you know what is the value of this one?
That's
It's somewhere around 1.41 and keeps going on.
yeah.
Yeah. If you divide, let's say, or let's say square root of minus 3. So things which cannot be represented in a simpler form, like a decimal, or some of the numbers that you would have seen, it will be like 1.41 and then recurrence on the top of that. That is, it keeps on repeating. Yeah.
Yeah.
So in simple terms, the numbers that can be plotted on a number line, those are called rational numbers. And the numbers like square roots and all, which doesn't give you a finite answer, I mean,
Yes.
those are a part of the category called irrational numbers. We'll probably park this here in terms of just for information. When we do a little more sums, I think it'll make it more clear. Okay. Yeah.
Yes.
Now, reciprocals. Reciprocals. What is the reciprocal of this?
That'd be 1/2.
Yeah. So basically, reciprocal is nothing but a dance form. When you
Mm.
make the dancer flip, yeah, yeah, any number
Yes.
x, reciprocal of x, 1 by x.
Yeah.
Now, 1 by x, what will be the reciprocal of this? Again, it's all about flipping it. Yeah,
Yes. It would be X.
it'll be x. So, reciprocal, when you talk about, you just imagine there's a dance happening. Somebody is flipping upside down. That's it. Yeah. Now, so that completes the first chapter for numbers. Okay. Our first subchapter says identify and use. That is where we talked about different types of numbers, LCM, SCF, common factors, cube, square numbers, and whatnot. Now comes powers and roots. Okay. So this is where we'll talk about square, square root, cube, cube roots. And then we'll also touch upon something called exponents. So let's look at powers and exponents. Okay.
Yes.
So far, so good. Anything that is not clear, Peter?
No, I think so far it's like it's okay. Yeah.
Okay. Yeah. Okay. And again, it might look like I'm trying to make it very simple or I'm talking about childish concepts. Uh, that is my goal. I have to make things look very simple. Okay.
Yeah. So far it is pretty simple. It's
Yeah.
easier to understand.
Yeah. Okay. That's good. Now, s- squares and roots. Sorry, powers and roots. Anything to the power this. Very simple.
Yeah.
That number is being multiplied by itself that many times. 3 to power 6. So that means 3 is getting multiplied by itself 6 times.
Mm-hmm.
Yeah.
Mm-hmm.
There's nothing fancy about it. If I somebody says 4 to the power 3, 4 is getting multiplied by itself 3 times. Yeah. So there's no restriction in math. You can deal with a number like 2 to the power 2009 also. Yeah. You
Yeah.
might not enjoy doing it, but yeah, I mean, there's no restriction as such. You can have as many powers, as many, I mean, as high a value for exponents as possible. But
Yeah.
there's no restriction. Eventually, in fact, from a practical usage point of view, you would deal with things. Why do I keep writing two all the time? You will keep dealing with things like numbers with power 2 and 3. These are
Mm-hmm.
very commonly used powers. So power 2 is a square. Power 3 is called cube.
Mm-hmm.
So it's called a square because no, it resembles pretty much with a square in geometry, where you have length and width both same. And you would remember, right? The area of a square is also length into length,
Yeah.
length square. So that is why this power is called a square. It resembles with a square. Yeah.
Yes.
Now, if you come to a cube, uh, we are talking about three dimensions right now. Not sure if you have got a chance to. mm, I'm sure you would have come across this. So a cube is nothing but a square extended, or no, so much so that length, width, and height all are same. Yeah.
Yes.
Like I mean, it resembles with an ice cube, right? I mean, in the fridge, refrigerator, you have those. In ideal cubes would be like the small pieces of ice which will have
Mm-hmm.
same dimension all sides, or something like a dice that if you would have used. Have you played Ludo or
Yep.
something later? Yeah.
Yeah.
So you have all the six sides which are very much identical. Every side is a square by itself. Yeah.
Yeah.
And if you look at length and width, if you count one as length and one as width, and this as
Mm-hmm.
height, you will see all of them are same. And
Okay.
volume of a cube is length times width times height. And
Okay.
length, width, and height all are same, so it is length cube. So that is the reason why anything to the power 3 is called a cube, which resembles pretty much with the cube, which has same length, width, and height, and the volume of that is length cube. So a length into length into length. So that's why it is called cube. Okay. So
Mm-hmm.
again, square and cube, I'm sure you were knowing. I was just
Yeah.
relating that with something that we see in our surrounding, and we can relate to that. I'm sure you would not forget this. Okay. Now,
Mm-hmm.
we were trying to learn numbers, square and cube, but what I kind of forced you to is relate that with the square, so that the area of a square is length square and volume of a cube is length cube. So you can relate that. Okay. This formula you will probably remember a little longer. Now, if I say something to the power 2, that is square, square 4, 4 square or whatever you call it. Yeah. 4
Mm-hmm.
square. Now look at this. 4 square is what? 4 into 4? That is 16.
Yeah.
Like we talked about reciprocal, right? Here let's talk about the reverse of this, meaning 4 square of 4 gives me 14. If I let me put it this way, 16, or this is 4 to the power 2. Okay. Now, ah, what would I do? Okay. So this is 16 to the power 1. What happens if I give 16 to the power 1 by 2? Or um, let me remove this one. This is not equal to this. What is the value of 16 to the power 1 by 2? Or let's put it differently. 4 to the power 2 is 16. If I say what is the value of 4 to the power 1 by 2, what will that be?
Oh, probably like half of 4.
It is not half of 4. We'll probably do a double click on that when we talk about exponents, but actually, anything to the power 1 by 2, whatever you see in the denominator, that is what is finding the root of this. Meaning, um,
Mhm.
meaning 4 to the power 1 by 2 is equal to this. We are trying to find out the square root. I mean, in case of square root, you don't necessarily have to write a 2. By default, it means square root. Okay.
Okay.
But this is what we are trying to do. Anything to the power which is reciprocal or an inverted number, right? That is trying to find out the square root. So
Okay.
now let's do it this way. We are trying to find out this. Okay. That means we are trying to find out square root of 4. Now, can I, is 4 a square number? I can write this as this, correct?
Yes.
So if I want to knock off this guy, this square root guy, right? This looks like a snake. I
Yeah.
don't need this snake. Then only weapon I have is this power 2. That becomes 2. The square root of 4 will be 2. Now let's look at this. So let's say somebody says find out. Let me not talk about that power 1 by 2. Okay. Let me not talk about 9 to the power 1 by 2. I'll just talk about this. Okay.
Yeah.
Okay. So I know I might be confusing you, but there's a reason and purpose to it.
Yeah.
So let's say I have to find out the square root of this. I want to kill this snake. Yeah. How do I kill the snake? I need to have a I need to have a power 2. This
Mhm.
this is square root, so I have to have a square to kill the square root.
Yeah.
Okay. So now I think I might be making a little more sense. If I have a square root, you have to find out a square root. I can convert that into a regular number if I can find out the square, because only a square can kill the square root. Only a cube can kill a square cube root. Okay.
Mhm.
So now let's do this. I have to find out the square root of this one. So a square root, this square root I can kill only with a square. Meaning, can I convert this number into a square? Yes, I
Yeah.
can. So if I have a square, I can kill the square root. Okay.
Yeah.
So this becomes 3. So now let's look at 27. If somebody says find out cube root of this, so that is when you have to put this number. Okay. It is
Okay.
just reverse of what we do. Okay. So now if a square of a number is this, a square root of number would be, oops, a square root of the same would be this. I'm saying 7 square, this is 7 square root of 7. Okay. I'm not saying these two are same. I'm saying representing it. Okay. Somebody says 4 cube. Cube root of this will be like this. You'll write like this. Okay.
Yeah.
So this is representation for a square. This is representation for a square root. This is
Uh-huh.
representation for cube. This is the representation for cube root. I have not said that they are same. Okay. They are not same. Okay.
Yes.
Now, what to notice is pe- people might you might get a question paper which says find out the square root, and there's no 2 here. When there's nothing written here, that is default assumed to be square root at 2 basically. If you have To find out a cube root, it will be 3 written here explicitly. Okay.
Mhm.
Anything to the power 4 is this. If I have to invert this, people might say that, okay, find out. I don't know what is it called in mathematical terms, but this is just reverse of this. Okay. So basically, you can, if let's say somebody says find out this, okay, what I have to do is this. I'll probably be able to explain this better when we talk about exponents. Okay.
Okay.
But in simple terms, if I have to find out this, I have to find out a power of 4. Okay.
Yeah.
I have to convert this number into power of 4 if I can. And this apparently becomes e to the power of 4. So then I can knock up the snake. I can kill the snake. This power and this power kills each other. And my answer is 3. So we'll keep that as information. Let's look at some squares and square roots and cube roots. Okay. Let's say somebody says find out the square root of this. So what you will notice here, there's no 2 here. You might have a 2 written or you might not have a 2 written. Both are the same. Okay. So for the sake of optics, I'll assume that there's a 2. Let's write a 2 just for our understanding. Okay. Now, if I have to kill this snake, I and with a power 2, or this is a snake with 2 eyes or 2 teeth, yeah, poisonous ones. So if I have to kill this snake with 2 teeth, I need 2 teeth as well. Okay. Meaning if 49 is equal to 7 square, right? 7 to 7 is
Mhm.
49. So I can write this as 7 square. Now I have the weapon for killing the snake with 2 teeth. So
Yeah.
it becomes this. Okay. So find out the square root of this. Same thing. This is a snake with the 2 teeth. I need 2 teeth as well. 25 is what? 5 is square. I have 2 teeth. I can kill this. So I will say 5. Done. Okay. Now, same way cube root. Let's say find out the cube root of 27. And when they say cube root, they will explicitly write 3. That's the only way they can represent cube root. Okay. So this is a snake with 3 venomous teeth. Okay. You need 3 weapons for this. Meaning, can I convert 27 into a number which is a power of with power 3? 3 into 3 is 9, into 3 is 27. That is 3 into 3 into 3. I mean, you can do it the way you're comfortable. Okay. So you can do it like a math. So this is 3 into 3 into 3 is 3 to the power 3. So I have three weapons for killing this guy with 3 teeth. Done. So
Okay.
I knock out these 3. Now, why I was telling you all this crappy stuff was because tomorrow somebody might trick you and say, find out the 5th root. Okay. I'm just making it up of this. This is not square root. This is not cube root. This is the root to the 5th level, actually. Right.
Mhm.
But then that is when whatever I told you that this is a venomous snake with 5 teeth. I need 5 weapons too. So can I represent this number as a power of 5? That will show me that I have 5 weapons.
Okay.
And then this is actually the number I chose, this 100,000 is actually 10 to the power 5.
Okay.
So then you have 5 weapons for those 5 teeth. Your answer is this. Yeah. So be it square root, be it cube root, it's all the same. You just have to look at this as a reciprocal of powers. Power 2, the inverse of that is square root. Power 3, inverse of that is cube root. Power 4, inverse of that will be root to the level 4, or whatever you call it. I don't know if there's a mathematical term for defining it. I can try finding it out, but yeah, I mean, beat any power or any universe of power, that should not be bothering us. Yeah. So far, so good.
Yes.
Now we covered this chapter very quickly in 10 minutes. So now are we good? Do you have some more energy left? 10 more minutes
Of
to,
course, yeah.
yeah, okay. But so far it's easy to interpret and appreciate, right?
Yes.
Okay. Now, anybody says find out square root of 81, you don't have to overwhelm yourself by figuring out what to do. No. That is where all that we have learned is this, that okay, nothing is, this is a snake with two teeth. Can I break 81 into power of 2? You don't have to again stress out too much. If you remember the table, okay, 9 to 9, that becomes 9 square. So I have two weapons for two teeth. Done. This is one way of doing it. Second way of doing it is try finding out factors. Okay. Try breaking it down. Okay. 81. I think if I divide by 3, I get 3 into 27. Okay. Can I break it further down? Yeah, I can break it. 3 into 3 into 9. Okay. Can I break 9 also further? 3 into 3 into 3 into 3.
That
And
would
then you
be
can
2 to the power 4.
3 to power 4. This becomes 3 to power 4. But I would not want to do that. What you will do is once you break it down into smaller pieces, right? Then you can group things. Okay. Oh,
Okay.
these two can be together. So this is 9, this is 9. So 9 into 9 is 9 square. And you can break it down.
Okay.
When we talk about exponents, that is when we will learn something more, and that will also help. But net what I was saying was, if you have to find out a square root or a cube root, you have to convert the value into in the form, the whatever you have to find out the square root or cube root for, you will convert that to a square or a cube of some other number, and then you can think of it. Okay, now I have got the square, so this will help me nullify it, or no,
Okay.
kill the snake with the weapon I have. Yeah. I mean, your
Yeah.
weapon has to be equally powerful as the snake, right? You cannot find out a cube root with like this, right? You don't have weapon
Mhm.
here. You have only power one. You have one power. You are trying to fight with somebody who has three powers. Yeah.
Yeah.
If you convert that to power three, and then you have equal number of power to compete. Yeah.
Yeah.
So that's the the playful way of looking at maths. Yeah.
Hmm.
Now let's look at exponents. Let's uh, if I tell you 2 to power 14 into 2 to power 28, what will be the answer? Do you remember?
That would be two to the power 42.
Okay, then I know you know the concept. Yeah. Okay.
Yeah.
Now, if I say 3 to power 18 divided by 3 to the power 7, what
That's
will that be?
3 to the power 11.
Okay. And if I tell you 6 to the power 4 in the bracket to the power 2, how much that will be?
6 to the power 8.
Okay. I'm just checking, okay, what all I need to tell and what all you already know, okay?
Okay. Yeah.
Yeah. So, okay. Now, if I tell you 10 to the power 0 will be how much?
That'll be 1.
Okay. If I tell you this to the power 0, how much that will be?
Uh,
Let me try confusing you a little bit, okay?
0.
1000 to the power 0 is how much?
1.
Okay. 0 to the power 0 will be?
What 1 as well?
No.
No, no, 0.
cannot see this number is so powerful and so shameless at the same time.
Yeah.
If you have 1, you write a 0 here, becomes 10.
Yeah.
Write a 0 here, no meaning. Nothing changes.
Mm.
So that's why I was saying this number is so powerful and so shameless at the same time. Yeah.
Yeah.
So here, 0 by itself has no meaning to it. Okay.
Okay.
So that's why if you put a 0 after a number, it makes it bigger. If
Okay.
you are only dealing with 0, 0 by itself has no meaning. So that's why
Yeah.
it will be 0.
Okay.
Yeah. So that's why I was trying to confuse you. I told you, right? That 10 to the
Yeah.
power 0 is 1. 1000 to the power 0, 1. 1 million to the power 0, 1. 0 to the power 0. In flow, you'll say 1. But that is not the answer because 0 by
Yeah.
itself has no meaning. Yeah.
Yes.
Now, let me do one more trick and
Okay.
see if you are able to prove me wrong.
Okay.
10 to the power minus 2. What is that?
That's 10. It's 1/10⁻².
Okay. That is good. So, I think then I have no way to confuse you. Okay. I think you
Mhm.
know it all. And
Okay.
it's good that we are doing a recap. Okay. So
Alright.
now, whatever we saw, and you are very clear with the exponents concept. So
Yeah.
I'm just doing a recap here. If
Okay.
I have a number to the power
Mm.
m, and if I multiply that with another number, same number with the power n, this
Yeah.
gives a to the power m
Plus
plus.
n.
This is the one rule that you already know. I'm just putting that in a form of a formula. Okay.
Okay.
If I have a to the power m divided by a to the power n, the second formula that you already know, it's called a to the power m minus n. Yeah.
Okay.
And the third formula is if I have a to the power m in a bracket to the power n, this makes it a to the power m into n. Yeah.
Okay.
Because that's what you told me, right? If you have 4 to the power 6 to bracket here, you said it will be 4 to the power 12, which
Yes.
is m into n. So only thing that we have to always keep in mind is this. If we are looking at this multiplication, right, exponents makes our life much easier. We can do much faster calculation, right? Imagine if somebody had to calculate 2 power 16 into 2 power 226. If it was to be done manually, that would have been a nightmare, right? I might have spent the
Yeah.
whole day doing it. But then exponent makes it easy, saying, okay, fine, why do you have to get to that kind of number? Anyway, you'll not be able to read it. So this
Yeah.
is 2 power 42. Done. Looks much simpler. Now,
Yes.
if you have a lot of time in the world, go on multiplying this many times and find out what that is. Yeah. Otherwise, this is the answer. Yeah.
Yeah.
The only care we have to take is make sure that when you're using exponents, make sure your base is the same. This is the base and this is the other exponents, right?
Yeah.
So your base is the same. Then only this formula works like magic. If you
Okay.
end up overlooking something like this could be a this could become an oversight, and you might end up saying, okay, yeah, 3 to power 2 plus 3. Yeah,
Mhm.
it's a minor oversight. So always make sure that when you're trying to use exponents, ensure that your base is the same. Yeah.
Okay.
Now, so this part Now, what I was trying to tell you was this. Mm, I'm just thinking, shall we do this or shall we not? Mm, no, let's not worry about it for now.
Okay.
because there are a lot of things that we can learn when we learn calculus. Okay, so
Okay.
let's overwhelm ourselves by looking at too many things.
Yeah.
So just to do a quick recap of what we did today, we just did a quick revision of different types of numbers. We looked at natural number, whole numbers, integers. Uh,
Mhm.
we looked at rational number, irrational numbers, um, decimals and fractions. We did not cover, but we know it already, right? So that's why I did not. Then looked at the difference between the two. Then we looked at the powers and roots. So
Yeah.
we looked at squares, cubes, square root, cube root in a more playful way, so that we don't forget. And when I was saying this, right, something like, so this is reverse of power 4. So
Okay.
this is called root 4. Yeah, power and root, right? So power 4, this is root 4, root 5. So you can represent it that way. You can think of it that way. Yeah.
Okay.
So then we looked at powers and roots, and we did a quick revision of exponents also. So
Yeah.
that brings us to the end of the class for today. In the next class, we will look at estimation and limits of accuracy. That will cover the first chapter actually for us, which is on
Okay.
rounding. Yeah,
Yes.
and we should be able to do little more than that, because just estimation and limits of accuracy will be a very quick thing.
Yeah.
Now, Riddhi, tell me one thing: how we can do practice of what we learn. Meaning, when we say uh, practice, meaning I'm not wanting to give you a lot of homework, but I want you to do some sums or exercise after the class, so that you can feel confident that yes, whatever concept I have gone through, I'm able to apply that and do the sums very quickly. Even if you do it for 30 minutes, that's more than enough. But I want you to tell me how we can do, some assignments, and you can send those to me. If you're getting stuck somewhere, let's say you're trying to solve a sum, and you get stuck somewhere, you can
Yeah.
send it to me, say, Uncle, this one I'm not able to solve. Do you have a
Okay.
way to solve it? So I'm just trying to make sure that whatever we learn, that we are able to apply and ensure that we have learned it right.
Yeah.
You would have some exercise book, in the books itself you'll have some exercise and all, right?
Yes.
So I would suggest you do that exercise, and get my WhatsApp number from daddy, and
Mhm.
then after you do the homework, after you finish those exercise, take a picture of that and send me in WhatsApp. Okay,
Okay.
that way I'll get the confidence that yes, uh, whatever we are learning is helping. And if you
Okay.
get stuck anywhere, you can send me that question in WhatsApp, say, Uncle, this one I'm needing some help.
All
um,
right.
if I'm in the office, I might not be able to answer immediately, but probably during the evening when I come back home, I
Mhm.
will try solving that for you. Yeah.
Okay.
So and another thing is, this video I will upload,
Yeah.
which you can watch offline, just to to do a recap, or not any revision, anything that you think that I'm forgetting or missing on. You can look
Okay.
at. So this becomes a reusable artifact for you whenever you want to revise a concept. Okay.
Okay.
uh, and then your parents can also see what we're learning in the class, right? I mean, it's
Yeah.
so that way, it actually helps us build that, what do you call, confidence to do things in a very transparent way. Okay.
Mhm.
Whenever you do some sums, whenever we learn something, you can go and challenge your daddy also, saying, Daddy, I have learned this concept, give me some sums, let's see if I'm able to solve them.
Okay.
Yeah. I want all my students, all my kids in the class, I call them kids, right? I don't call them students. You guys are like my kids.
Yeah.
So I call my kids to do math in a more playful way, so that you don't get stressed out. Math is not a subject you get stressed out. Okay.
All right.
Yeah. So that's what brings us to the end of the class. We'll meet again next week, same time.
Okay.
Yeah.
Yes.
And I'll upload the video in a little bit.